We will solve this today's Leetcode problem. This is Leetcode medium, longest continuous subarray with absolute difference less than or equal to limit, right? So the question is, we have given an array of integer nums. An integer limit returns the size of the longest non-empty subarray such that the absolute difference between any two elements of this subarray is less than or equal to limit, right? So basically the question is asking to find the size of the longest subarray which fulfills this condition, the absolute difference between any two elements which whose subarray is less than or equal to its limit. We have given some limits, and if the subarray we choose, it should must fulfill this condition, right? So the basically the condition is that if we choose two elements from that subarray, any two elements, it difference between absolute difference between both of the elements should be must be less than or equal to the given limits. That's the condition, right? And we need to find the longest subarray. Okay, so basically if we see the first example here in this, so 8247 is given and limit is 4, right? So if I choose we want to choose any subarray. So how many subarrays can be possible? 8247, uh, 8 is a subarray, 2 can be also subarray, 4 can also be subarray, 7 can also be subarray, 8 2 can be also subarray. So subarray means the continuous elements, right? Subarray means the continuous element, consecutive continuous elements of continuous elements should be present, right? This is not subarray. This is not a subarray. This is not a subarray, right? This is a subsequence. This is not a subarray. Subarray is continuous elements, right? So 8 2 is subarray. 8 to 4 is a subarray, right? 8 to 4 is a subarray. 8 to 4 7 is a subarray. These are all the subarrays, right? So this is how we need to find the maximum possible length. So we don't need to find subarrays. We need to just find the length of the subarray which fulfills these elements, right? So basically whenever you see, whenever the first thing is that we will generate all the subarrays and check which has between two elements of the subarray is less than or equal to limit, right? Sure. So but that will take O of n square for for taking each and every subarrays. That will take O of n square. And if we check the constants here, it is 10 to the power 5. So basically 10 to the power 5 O of n square is very, it must will give you definitely a TLE, right? So we can't use generate, or we can't check all the subarrays, right? Now the second thing is that one thing you see here, if you observe, the absolute difference between any two elements must be less than or equal to limit. It means if I choose any subarray, any subarray, and take difference of its minimum element, minimum and maximum element, minimum and maximum element, take difference of its minimum and maximum element only, and check that whether it is less than limit or greater than limit. Then we am confirm about all the difference between of any two elements of that subarray, that it must be if it is less than limit, it must be less than limit. If it is greater than limit, if it is will be greater than limit, right? Because if you see here, we need to take absolute difference of any two elements of the current subarray, which must be less than or equal to limit. So if the difference between minimum and the maximum element of a particular subarray is less than or equal to its limit, I'm sure about that if I take any of the elements in that subarray, it will a difference between with all the elements will be less than this limit. I'm sure about that, right? So if this difference is less than or equals to its limit, the given limit, then I'm sure about that. I'm sure of that about that all the elements, difference between all the any two elements, difference between any two elements will be must elements will be definitely less than or equal to limit, right? less than or equal to limit, or just like this, right? Less than equals to limit, right? I'm sure about that. And if this is greater than greater than this limit, so I don't need to check any of the elements, because it is asking to check any two elements, and these two elements is present in that subarray. If it is greater than limit, so why would I check for further elements, right? So I will check only for this minimum and the maximum element present, if I choose any subarray, right? Okay, this is the first observation, that I don't need to check each and every elements, each and every absolute difference. I will choose any subarray. I will choose I will choose only two elements, which is the minimum and the maximum element of any subarray, right? So basically, I will I will consider taking only one difference, which will be between which will be between the max and the mean element, max and mean element of a particular subarray, right? Particular subarray, right? And will act accordingly, right? Will act accordingly, right? Okay, one thing is clear to our mind, right? Definitely one thing is clear to our mind, right? Okay, the first thing is clear. Now the second thing, that we can't check for each and every subarray, right? Which can represent. So what we can do, okay, what we can do, so basically, whenever you see subarrays, which algorithms came in your mind, right? Which algorithms you thought of whenever you see subarrays, or the finding the continuous subarrays, or uh, subarray less than sum, or something like that. You see that we have a limit, given, we have something, we need to find the subarrays, and we have a limit, and we have a limit. It means, for finding subarrays, can we can we think of any algorithm, can we think of any algorithm? So let's see. Let's take an example of anything. Like, let's take example of this. Right? Let's take an example of this. So for finding its limit. So suppose, like, let's take this 10, right? Let's take this AB, right? 10, 1, 2, 4, and 7, right? So when I take 10, when I take only 10, when I take only 10, the thing is, when I take only 10, the difference between its maximum and the minimum value is 10 only, which is 0, which is less than limit. It means one length is possible, right? One length is possible. When I try to take 1, 10 minus 1 is 1, 5, 9, which is greater than limit. It means I cannot consider this 10 and 1, right? It means I cannot consider this 10 and 1 subarray, right? What does it mean? If I cannot take 10 and 1 in take 10 and 1 in one subarray, it means what does it mean? It means I can also not take 10 1 2, 10 1 2 4, 10 1 2 4 7. It means any subarray which contains 10 and 1, I cannot consider that. I'm sure about that. It means if I cannot consider 10 and 1 in one particular subarray, it means I cannot take any subarray which contains 10 and 1. I'm sure about that. It means either 1 need to remove, or either 10 need to remove, of course. So if you remove 1, we have already checked for 10, right? So if I remove this 10, so now this one is only one limit. So this is 0. Difference between two elements is 0, because 1 minus 1 is 0, right? 1 minus 1 is 0. Let's write in other, right? So this is 1 only left. So 1 minus 1 is 0. It means the length is 1 is still, right? Answer is storing the maximum element. Now, when I try to take 2 with the elements, because I need to find the maximum length of the subarray, so I will try to take more elements in my subarrays. So if I try to take 2, so 1 and 2 difference is 1. So that would be, but that would is less than 5, right? So it means 1 and 2 sub array is possible to take, right? Because it is less than the limit, right? So it means what are the length of the current sub array? 2. So answer will be 2, right? Now I need to check for further elements to include whether I can include or not. So I will include 4. Now this 4 is maximum and 1 is minimum. So 4 minus 1 is 3. It means I can take this because limit is less than 3. So I can increase my answer, which is 3. Okay. Now I can check for further elements because I need maximum length, right? So I will include for 7 also, right? So when I include for 7, 7 minus 1 is 6, which is greater than limit, which is greater than limit, right? Which is greater than limit. It means if I can't choose 1 to 4 7, if I can't choose 1 to 4 7, can I choose 1 to 4 7 and 2 also? No, I can't choose because this will also give me 6 limit, because 7 minus 7 and 1 is still present here. It means if it is not if we can't take this subarray, we can't take all the subarrays which contain this particular 7 and 1 element, right? That's the same condition with this, right? It means it means it means I need to remove what? I need to remove some elements from this subarrays. I need to remove some elements from the subarray, right? I need to remove some elements from the subarray. So what will I remove? I have already checked for 1 to 4, right? So it's not use case for to remove 7. So I will start removing from the first part. I will start removing from the first part because we have already checked for 1 to 4 and 1 to 4 7, but we haven't checked for 2 4 7, right? We haven't checked for 2 4 7. We have checked for 1 to 4 7 and 1 to 4, but we haven't checked for 2 4 7. So we will remove this one, right? We will remove this one. We will remove this one and check whether we can form this subarray or not. If I remove this one, it become 2 4 7. Now the minimum element is 2 and the maximum element is 7. 7 minus 2 is 5, which is less than equals to 5. It means I can consider this subarray. I can consider this subarray. It means if I consider this subarray, the length is 3 and our answer has already 3. It means no effect. But I can check for, we have extra elements present all here. So we will check for further elements. So if include this 2, still it is minimum element is 2 and 7 is maximum element. So 7 minus 2 is 5, right? 7 minus 2 is 5. It means we are under the conditions, and but the length is 4 now. So answer would be 4. And if you see, we have got our answer 4, right? So basically if you have followed till here, you must understand that which algorithm is this. This is the sliding window approach. This is the sliding window approach. And this is the basic. This is one of the uh, most common use of sliding window approach. Common use of sliding window approach, right? So this is the very basic questions of sliding window, because whenever you find a sub array, that you need to find whenever you have given a limit, and you need to take the largest continuous, or length of the continuous, or true or false, something like that, and you got a limit. You will use a sliding window approach. You can think of sliding window approach for sure. For sure you can think of sliding window approach, because that would be definitely be that would high chances of using this algorithm, right? Sliding window approach, right? So basically it's something like sub array sub array sum less than k, or sub array sum of uh, greater than k, something like that. This is same as the same problem, right? But the thing is, so what we are doing, we are just shrinking. We are just we are just shrinking. We are expanding till we are expanding our sub array. We are expanding our sub array when my condition is fulfilling. My condition is fulfilling, and we are shrinking when we are shrinking our subarray when my condition is not fulfilling, right? This is the fulfilling. This is the main logic of sliding window approach, right? This is the main logic of sliding window approach, right? So if you uh, if you see that we are shrinking our subarray, and we are when my condition is fulfilling, and we are shrinking our subarray when my condition is not fulfilling. That's the motto of sliding window approach, and that we were using here. But the thing is, if you see here, for each subarray, whenever we are either expanding or shrinking, we need a minimum element and the maximum element to check the difference. For checking the difference is less than or equals to limit or greater than limit. So how we will maintain that? So basically we need to so I'm sorry about that, that I will use a sliding window approach. That's the basic sliding window approach, right? And we need to here do one more thing. Do one more thing. What I need to maintain, i need to I need to maintain the minimum number and the maximum number of that particular subarray particular subarray. How we will do that? How we will do that? So see here in this, when we are taking this uh, when we are taking this when we are taking this if I so what can you think in your mind at which data structure maintain minimum and the maximum number? So if you think many data structures, what are the data structure we have that maintain minimum number and the maximum number? The first is, of course, heap, max heap, and mini. These are the two. Second, map, like it stores it whenever we store the elements. It it adjust at maintain the order in sorting order in maintain the order of it sort the orders of it sort order it sort all the elements in order, elements in increasing order, right? On the basis of key only, right? Increasing order, right? Third third is set, multi-set, right? Multi-set. What does why with this multi-set not set? Because it can be possible that there can be multi elements present. And set, what does set do? Set stores distinct elements, but multi-set can store duplicate values, right? So it can store duplicate values in sorted order, and sorted way. So we have three data structures which we can use right here. We have which can maintain the minimum number and the max number. So we will use a map here. You can use anything instead of map. You can use multi-set, you can use heap. We will use map here, right? So let's see how we will use a map, right? So in map, it stores in it stores in sorted order, right? So whenever we got 10, if I got 10, I will store this 10, right? Then when I got 1, and so this 1 is here, so we will store this 1. So but this 1 will store in sorted order, so that will be 1 and this 1. But now this see, 10 and 1 difference is 9. Difference is 9, which is greater than this limit, right? It means I need to shrink this side, this window, right? So I will delete this 10. So when I try to delete this 10, I need to also remove it from map. So when I remove this 10, I will decrease this number from 10 to 0. And when it decreases to 10 to 0, it means I don't need further this number, same number I don't need further, right? If I don't need this further element, I will delete it. Right? Now we have left 1. Now the difference would be 1 and 1, which is my 0. So it is available. It means the answer would be 1, right? Now this 1 can be take again for 2. So this 2 is here, and 2 will be inserted in my map. So 1 and 2, 1 is the minimum, 2 is the maximum. Again 1, which is limit under limit. it becomes 2. Now we need to take 3, sorry 4. The 4 will also be inserted in map in sorted order. So the maximum element is 4, 1 is in lower limit. So 4 minus 1 is 3, which is less than 5. So answer would be 3. Now again 1 to 4, 7 can also take. So we will insert this 7 in my map. Now maximum element is 7, minimum element is 1, which is difference is 6, which is already still greater than limit. It means I cannot take 1, I cannot take 7, right? So if the limit is greater than this, so it means I need to delete something. So what I will do, I will shrink the sliding window. It means I will delete this one from the starting point. So I will delete this one. Now when I delete this one, it count becomes 0. Now this becomes 0. It means I don't need this one in my map. Now I will delete this. Now the sorting order is 247 now. Now the 7 minus 2 is 5, which is still in the limit, so we can take this. And but the length of the Subarray is still 3, so it will be not changed, right? Now we have already taken 247. Now can we take 2? If I take 2, the 2 is already available in map, so it will get incremented only. And 7 minus 2 is still 5, which is greater than which is under limit, right? Less than equals to limit. It means 2472 can be taken as a subarray whose length is 4, so maximum length is 4. So we got 4 our answer. So what we are so why we are taking map? Why are we taking map? To maintain the order, to maintain the minimum and maximum elements for taking difference between them, taking difference between them, right? Difference between them, right? So that's why we are taking map here. You can use multiset also, you can use heap also, right? It is on upon you. I am taking map, right? So let's just try to implement that, right? So basically it's simply a sliding window, which we use, definitely use a template for that, right? So basically what we do, we take 2 pointers, right? We take 2 pointers, which is a j, a answer variable to store the length, maximum length, which is 0. And also I need to take a map to store the minimum and the maximum element. So the basically, if you see the template of sliding window, it started from 2 pointers. So first pointer is which get incremented, which expands the subarray, which is I is equals to 0, and j is equals to 0 is something which shrink the sliding window, right? Which shrink the sliding window. The first thing that we will insert our elements in map, right? The first thing is we will insert the map. And second thing, I need to take a difference, right? I will take a difference. So the starting element, the start element will be amp dot begin. This is the start element. So amp dot begin gives iterator, it gives iterator, right? And this end is amp dot end. So this amp dot end, it also gives iterator of the last element where it is not, where the element is not present, right? So I need to decrement one iterator by one position back, so that I can get to the last position element, right? To the last position element. So amp dot end goes till here after this element, after this 7, right? At the last where no elements is present. So I need to uh, to make this end at 7. So I need to decrease by it 1, so that it will point to the last element. And at last I need to take a difference, which will be end minus end first, which is, it will represent a key, minus start first, right? So the first represent key, the second represent the number of counts which we do this way, right? So this is the difference. Now what we will check, we will check that whether this difference is greater than limit or not. So if it is greater than limit, we will simply shrink this subarray, because this subarray cannot be taken as, right? So what we will do for shrinking, we will start deleting the elements from the first part, right? So what we will do, we will just do minus minus here, that we will for deleting it, it means we will just decrement the count of that nums in map, right? And if the nums j is 0, it means we don't have any elements of this nums j in my map. It means I can remove this. I can remove this nums j from my map. Why we are doing this? We are doing this because if we don't remove this, see here, if I don't remove this one from my map, so this 1 0 would be present, and when we are checking for difference, it will give me the minimum element as 1 and maximum element as 7. 7 minus 1 is still 6, which is wrong here, because we don't have 1 in my subarray, right? So we need to delete the 1 from my map if it is not present, if its count is 0, right? Now what I will check, I will need to update my difference. I need to update my difference. So for that, I will again use the same thing. I will again use the same thing, that I will start mp dot begin and mp dot end, and will be minus minus. Now I will check the same difference here, because difference would be updated now because I have removed the first part. So this would be like this, right? Now the difference is updated, and also we will increment my jth pointer, because it can be possible that this difference again is greater than this limit. So this jth would be again so till where we increment our j value, till our I values, right? Till our I value, because it would be shrinking, but it cannot go further beyond the ith limit. So that's the condition of this limit. And after this, I'm assured about that that this difference would be less than equals to this limit. So I would be storing answer a I minus j plus 1. So I need to store the maximum length. So I will store the maximum length, right? I will store the maximum length. So this would be the store the maximum length possible of the subarray. I minus j plus 1. Why we need to I minus j plus 1? Because this j plus plus will point to the this subarray. This j plus plus would point to this 2 point, this 2. When we are increment, this j will be at this, I will be at this. So I minus j plus 1, because it has started from 0 index, right? It has started from 0 index. So I minus j plus 1, and if I do simply I minus j, this 2 will be neglected, which we don't want, because this is 2472, right? So that would be I minus j plus 1, and which will be stored in my answer, and simply return answer. This is how we will solve this map. The map is extra here in template, because to because we want the minimum and the maximum element, and check the difference of between that, and check with the limits. That was the motto of this map, right? Let's try to run this and see we have implemented it correctly. Yeah, we have implemented correctly, and let's submit it. We have passed all the cases, right? And if we check the time and the space complexity, what will the time and the space complexity? So first thing is, we are taking a map, we are storing all the elements in my map. In the worst case, it can be possible that difference will never be greater than this limit. It means we have stored all the elements in my map, and after each insertion in map, it takes log of n to restore this. So after each insertion, it takes log of n, right, to short it. So we are inserting it n times, so that would be definitely of n log n, right? That would be definitely of n log n, for because we are using a map, right? The second thing, that we are iterating this 0 to n, is this I is definitely iterating from 0 to n, and this j will also be definitely started from 0 and can go to till n, right? Why I'm saying that? Because this will be not into I into j, it will be o of n till for I and o of n for j also, because only we are only started iterating this j to till I when this difference is greater than limit. It means this I can go till n, and this j can go till n also, right? So it basically it can go of O of n plus O of n. This is due to I and this is due to j, right? So that would be O of 2n. And yeah, we haven't this is the time complexity would be, and overall this would be O of n log n, right? And the space complexity would be, so the space complexity, we have taken a map that will store all the nums, so that would be O of n. And we haven't taken any extra spaces other than this, so that would be O of n, right? So these two are the time and the space complexity for this problem, right? So yeah, thank you so much. Bye bye.